Now we focus on additional applications of trigonometric functions. First, let's look at solving oblique triangles. Oblique triangles, they are not right triangles. So as we recall, we have solved right triangles. So if it's not a right triangle, it is an oblique triangle. There are two cases. An oblique triangle might be a triangle that has 3 acute angles, or a triangle that has 1 obtuse angle and 2 acute angles. So here, this is one case, right? We have 3 acute angles, but none of them is right triangle. So this is an oblique triangle. The other case is we have 1 obtuse angle and 2 acute angles. So I want to indicate acute angles with blue. Here you see 2 acute angles, but the obtuse angle with pink. So here this is a second case. 1 obtuse, 2 acute. But the first case, all 3 angles are acute angles. So either this case or the other case. And so no matter which case, how do we solve them? Solve a right triangle, that means we're given some information, we want to decide the unknown angles or side length. So the tool we need is the law of sines. The law of sines actually shows a relationship among the sides and angles of any triangle. That including right triangle. So no matter it's oblique or right triangle, so we can use this. So this, when you see these equalities, it shows actually 3 equations. You see this equals the other, right? So that's 1 equation. And then we can also show that this B over sine B is equal to C over sine C. That's another equation. And also A over sine A is equal to C over sine C. So we have 3 equations. So let's show them. So that is equivalent to 1 equation and the second equation and the third equation. So yeah, from this statement, that is the law of sine. Usually you see this law of sine written in this way, but actually it implies 3 equations there. It's very neat if we only look at this part, that is A over sine A equals B over sine B. If you look at this part, that means B over sine B equals C over sine C. And if you look at this, that is A over sine A equals C over sine C. And by the way, the capital ABC and the lowercase ABC, so recall that we adopt this custom that the capital ABC are angles of a triangle, and the lowercase ABC are respective sides. So you see the lowercase a corresponding to angle A. The lowercase b corresponding to angle B, capital B. And lowercase c is the side corresponding to the angle C, capital C. Yeah, so that's our the meaning of the lowercase and capital. All right, so we continue to use that method, and then we establish this relationship. So this law of sine shows the relationship among the sides and angles of a triangle, of any triangle. So if you look at this equation, you can flip it. For example, if I write sine A over A, then sine B, capital B, over B. So that's the same. So that means if A over sine A equals B over sine B, then sine A over A equals sine B over B. So we just flip each fraction. That means if these two quantities are equal, then their reciprocals are the same. So similarly, if we have this, then we can flip the fraction, can write the, instead of A over sine A, we write sine over A will be equal to sine C over C. So we can, instead of this, we can flip, and then sine B over B will be the same as sine capital C over C. So just because if two numbers are equal, then their reciprocals are equal. So therefore, we can have the alternative version of the law of sines. Yeah, so compare the version we saw earlier, and the alternative version is just a flipped version. You see, that is one way to express the law of sines. Here, after you flip the numerator and denominators, that's the alternative way to show the law of sines. Okay, so no matter which way, these two are equivalent. So you can choose based on the situation. You choose whatever format is the most convenient for you. Let's solve some oblique triangles. So when we solve oblique triangles, then we can see there are different cases. So sometimes we know one side and two angles. Okay, here I use the color, the right color to indicate that's the side we know, and the capital A's are the angles we know. So if we know one side, two angles, side, angle, angle, and we can solve a right triangle, that means we can solve for the unknown angle and the two other sides. Or possibly we can solve a different case. There's a side between two angles. Okay, so that is the case if we know an angle and the side between the two angles. So suppose we know two angles and the side between, then we can also solve an oblique triangle or just any triangle. So that's one case. If we put them in the same category, that will be knowing one side and two angles. The other category is that we know two sides. So could be side, angle, side. That means there's an angle between the two sides is given. So in addition to know two sides, the angle formed by the two sides is known as well. So that is side, angle, side. And another case is side, side, angle. So if we know the one side, the next side, and the angle. So that case is ambiguous. I will show some examples to explain that sometimes we have a solution, sometimes I have no solution, sometimes we have two solutions. So this one, it is called an ambiguous case, depending on the information given. And then we have possibly three sides. If we know three sides, what are we looking for? We're looking for three angles. That means we only know the side length of the triangle, but we don't know any of the three angles. So in the last situation, given three sides, we're looking for unknown angles of a triangle. So here, so just different situations when we try to solve. So in the following, I'm going to solve a case side angle angle. Also, let's solve angle side angle. So they're both in this category. That is knowing one side, two angles, right? So let's look at an example. So this example, what we know, this is side C, angle B, angle C, capital C. So let's highlight our angle. So B and C, capital B and C are given. And the side C is given. So all these are given. So what are we trying to determine? The remaining angle is A. So I want to use a different color. For example, if I use, okay, let's try a different, let's use blue for the unknown. So A to be determined. So if the A is the angle that is unknown, can we possibly decide what A is? Recall that the sum of three angles of a triangle is 180. So that means A plus B plus C should be 180 degrees. So if we know the B and C, we can certainly find the measure A. So all we need is to, so quickly we can find A. So afterwards, we are left to determine the length, the side A, the small a, right? That's the side A, and small b, which is the side B. So here, that's the step one. We're going to decide the angle A. So because the sum of the three angles is 180, then the only unknown angle is A. So we just use 180 minus B minus C, then we can get A. So it is, okay, just substitute the given angle B and C into this equation, then you can find A. So you see the B is 68.13 degrees. C is 71.90 degrees. And then we just determine the A. So after we subtract B and C from 180 degrees, we get A, which is 39.97 degrees. Okay, now we know all three angles. B and C are given. A is not found. A is found. So now the remaining is for us to find. Okay, we know our next goal is to find A, lowercase a. Let's think if we know that law of sine, let's use it. So A over sine A, right? Equals, we cannot use B because B is also unknown. So let's use C over sine capital C. So if we substitute the values we know, so A we don't know, but everything else we know already. So what is sine A? Sine A, capital A is found, right? So we can just put, so I'm going to use the color, whatever we know already. Let's put capital A was just found, that's sine A. And C is given, you see, the C is given. That capital C is also given. So if I put here, then you can see the only unknown is the lowercase a. Because all these green ones are quantities we know already. So we can just solve for the A. So we multiply both sides by sine A. Then the A can be found. A can be found. It will be C over sine capital C and times sine capital A. So this quantity times, we just simply multiply, you see, both sides by sine A. That's how we simplify it, because our goal is to get the A, right? So by multiplying both sides by sine A, we can isolate this A. So A will be this, and that's what we got. C over sine C times sine A. So now we put all the values. The values what is C? C is a 4.23. So you put here 4.23. What is capital C? Capital C is given. What is capital A? Capital A is found. So let's just give the equation. So this equation, as you can see here, it is color coded, right? So this is the only unknown we're trying to solve. And all the rest, we put values. We found this capital A, which is 39.97 degrees, and C is given 4.23, and capital C is 71.90 degrees. So with all these values, then we can get this unknown side. The unknown side length A is this quantity multiply this sine, the right-hand side, times the sine 39.97 degrees. So as you can see, this quantity is simply this, right? This. And this, both sides times the sine 39.97 degrees. So then that will make the left-hand side A, okay? So then we get A. Okay, so then if you have a calculator, you are allowed to use it, because this, you see 71.90 degree on 39.97 degrees, they are not special angles. And you can just use your tool, your calculator to find. The A is approximately 2.86 centimeters if that's the unit we're using. for this problem. And now what is left? That's a B. So very similarly, so to find B, we just need to get something similar. We put B here over sine B, right? So this is B over sine capital B equals C over sine capital C. So compare with this equation, you see how similar. So everything else is known in the equation except for the B. So we solve this equation. So B will be found to be C over sine capital C times the sine capital B. Yeah. How do we get that? So just from the equation, you see this equation, as long as we multiply both sides by sine capital B, right? Sine capital B, then we can get B on the left side. So the B will be solved. B will be just this. So then, which is that quantity. And then let's get the numbers. So this is the equation, and then multiply both sides by sine capital B. Then we will get, you see the right-hand side will be, yeah, this one multiplied by sine capital B, right? Sine capital B, which is 68.13 degrees. So then by solving this, you just use your calculator, you get this number times 4.23 divided by another number, which is sine 71.90 degrees. Then it's approximately 4.13 for B. Okay, so as you notice, when we solve for the unknowns, we for the convenience, we put the unknown in the numerator. Yeah, it's just for the convenience, but certainly it doesn't hurt if you use a different version. Suppose it's sine A over A, sine capital C over C. If you use the flipped version, right, instead of this one, if we use this, what's the difference? Then you continue, you still know that everything, right, except A. That's A is the only thing to be found. Yeah, so then you can write A, because we also know that when you have such a fraction, then your A times sine C capital C will be equal to the C times capital A. So we can write the equation like A sine capital C equals small c times sine capital A. So we can write that equation into a form like this. And then we can continue to get A, because A is the quantity you are looking for. So C sine A over, we want to divide the sine C, so we can get A. So you see it's the same thing. So we still get the same A, C over sine capital C times the sine capital A. So that's the same quantity we got earlier. But if you think this is easier to do, put the unknown in the numerator, yes, that's so you just get rid of this denominator, right? But multiplying that denominator both sides, that's a quick way to get the yes, you see that's the quick way to get the A. Okay, so so you see you have two versions depending on what is the unknown, and then you choose the version that is most convenient for yourself. So we just did the side angle case, right? Now next case will be angle side angle. See the difference? The previous case, side angle, right? Next case will be side between two angles. So you want to look at the next case, which is different. You know two angles and the side is between two angles. Okay, so let's look at the given information, given triangle, capital ABC, the angle, and the side. And let's look at the information in the graph. So here is the angle given, the other angle given, and side given. So you see the side B is between two given angles. So what is not given? What is not given is this, only one angle to be determined. That's easy to determine, right? We know this, the only one must be 180 degrees minus the C minus the A, angle A. So we just do a subtraction because the sum of the three angles is 180 degrees. So the remaining angle must be 180 minus the other two angles. So that's a quick way to get the angle first. Now after we do this, then we will know all three angles. Then what is next? Next is to find two other sides. Okay, so so the B, the angle, let's just get the angle B. Its exact measure is so you see the blue font. This B is unknown, right? Everything else. So then we just do the subtraction, we can get B. So 180 minus A. So this time, this oblique triangle has the obtuse angle. Okay, so minus 112.08 degrees minus C, which is 23.96 degrees. So the 180 minus A and C, then we get B. B is 43.96 degrees. So we get the B, and then next we need to decide A and C. Okay, so let's go to the figure. So it's easier if you look at the figure, we can write an equation that is useful for us. So the B is given, and this capital B is just found. So then we can use B over sine B, capital B. Right, so these two are known. Then what, the A is not yet known, but this A is found. So this A is to be solved. So that A over sine capital A. So I'm going to use the pink this time to indicate whatever we. So then we have only the blue A, the lowercase, this blue A to be found. So how do we find it? Then just multiply both sides by sine A. So if we multiply both sides by sine A, then you will get, okay, b over sine b, right? The right-hand side multiplied by sine a, then we'll cancel with that other sine a. So you have only the a. A is found. So a, now a is found, right? Notice that we know the capital A, right? And lower b given, the capital B given. So everything is now known. So we can determine the A. Okay, so that A will be found this way, and then we just plug in numbers. So yeah, so you see that's the A you want to determine. So if you want to put all numbers already, that's possible. So the capital A, we know it, right? All the values you know, you just put the values in. So the B, lower B is given 7.76. And then the capital B we found capital B, which is 43.96. And then you have everything but A. And the A, so when both sides multiply this sine 112.08 degrees, both sides of the equation. Then see what happens. Then the left-hand side will become A because we can cancel, right? So that's why you multiply 112.08 degrees, both sides of the equation. So the left-hand side becomes A. The right-hand side will become this quantity times the sine 112. So A is found to be 10.36 centimeters. In the problem, we are told the length of each side is in centimeters. So that is the unit for the triangle. Okay, we're not done because once we have found A, we still have a side to determine. So you see C is another side, this one. After we have found A, then we still have one side to determine. So this is our C and capital C. You see, the capital C is given, right? So we can just C over capital C equals, and now we can choose either A over sine A or B over sine B. Which one do you choose? I think I prefer to choose B. Why? Because you think, okay, we know A, we just, but the A was the one we just found. What if we made a mistake, right? So that's possible. So I don't want to use if there is a mistake in the solution in the A we just found, then that will impact our solution for C. So let's use what is given. If possible, use what is given. So let's use B. B is the length that is given. Sine capital B, but certainly this B is also the angle we just found, right? So hopefully we are not making a mistake. But anyway, so the principle is like, if possible, we use the most accurate values to do the calculation. So if you cannot avoid the value you calculate in the intermediate steps, then yeah, just use it. There's nothing wrong, but we just try to use whatever is given, right, to calculate some unknown. So this is an equation to find C. So now what is C? C, how do we find C? C is just both sides of the equation. Let's multiply the sine capital C. So I have then the left-hand side will become C, then the right-hand side will become this. So then we can find the C. That's the side length C. Okay, so that is solving that equation. See, this is the equation. C over sine capital C equals B over, this is a B over sine capital B. Okay, then we solve that equation for C. So we solved two oblique triangles. One is S angle angle. The second case is angle side angle. So both cases, we have only one side. And we know two angles, right? In this case, first case, we know two angles. A third angle is very easy to find. Then you're also supposed to find two other unknown sides. Here, the second case also, we know two angles and the side between the two angles. And then we can find the remaining angle and two unknown sides. And we used the law of sines. But now we have used the law of sines, so you have the ideas, and then let's try to understand the why we have this the law of sines. Let's just, okay, we will not solve more triangles, but instead we are going to, okay, I want to show you a picture, and this image will help you understand why this law of sine. So if we think a triangle, I'll just grab a triangle, then ABC, then I want to, suppose I draw this vertical line from the vertex C. So then we can call this one H. That's the head of a triangle. Suppose C is the base, and the capital C is the vertex corresponding to the base. Then we have this, and then, but it doesn't matter as long as we drop this H, and we can look at the H over B will be, according to our definition, H over B. For A, that is sine A. Right, and same thing if we look at the other side, this is a right triangle. You see, we have right triangle, two right triangles, right on the left side of this edge, on the right hand side of this edge. So the left side H over the hypotenuse is sine A. And same thing, H over hypotenuse, the other right triangle, H over A. So you see I'm looking at first triangle is this. The other triangle is this. So I have two right triangles. And on the left right triangle, then I got sine A. And the blue right triangle, it is H over A equals sine B. Yeah, equals sine B. Yeah, so the two right triangles based on the definitions of, definition of sine A and sine B, then we get this. And then what is H? By solving the first one, we see the h is, let me use a different color. So from solving this one, we get h, right? H is simply b sine a. Yeah. And then for solving this one, we also get h. H is a sine b. So the same h, but different representation. One is b sine a, the other is a sine b. So let's write this. I will just write b sine a. That is h, right? And a sine b. Also same h, this h. Then they are equal. That's, if they're equal, then what do we see? And we can rewrite this. So suppose if this is an equation, we can also divide, for example, divide sine A, sine B, both sides. Let's see what, divide sine A, sine B. Because you divide the same quantity, the goal is to make it a little bit easier to recognize. If I divide the same quantity, this equation will still an equation, right? So let's divide, then I can cancel something. So then this becomes what form? It becomes b over sine b equals a over sine a. That's the form we knew already. So that's the law of sine. You see, b over sine b is a over sine a. Yeah. So we just proved that a over sine a is b over sine b, capital B. But similarly, if you use another vertex, do the similar, the drop a hat, and then you can get the conclusion that, the two other equations, because you also want to show a over sine a equals c over sine c. You also want to show b over sine b, capital B, equals c over sine capital C. Yeah, so the other two equations of the law of sine will be derived very similarly. It's just to choose a different vertex. And then you do a similar kind of proof. So that is a proof of the law of sines.